Hello everyone. Today we will begin with the second PUC physics, electrostatics. So in that first chapter is electric charges and fields. So what are the learning objectives from this chapter is electric charge, Coulomb's law, electric field, electric dipole, electric flux and continuous charge distribution, Gauss laws and its application. These are the learning objectives we can learn in this chapter. So what is the meaning of electrostatics? It is a branch of physics which deals with the study of charges are at rest. It is called electrostatics. So in this electric charges we can learn charges and its properties, then methods of charging, types of materials based on conduction and electroscope. Electric charge is an intrinsic property that can attract or repel to any other material. It is called electric charge. So there are two types of charge. One is positive charge, another one is negative charge. So here you can see the examples. What are the properties of charge? Like charges repel, unlike charges attract. See, here I have taken two glass rods. You can take two glass rod and rub it with each other. So if you can take glass rod and a glass rod, so they can repel. Then glass rod and plastic rod. So glass rod is a positive and plastic rod is a negative, then it is unlike charges, then it can attract. So what is the first property? Like charges repel, unlike charges attract. So this is the first property. You can see a sign plus plus like charges, minus minus like charges, plus minus or minus plus unlike charges. So like charges attract, like charges repel, unlike charges attract. So this is the first property of charge. So now you can see one of the question is there. Two charged bodies A and B attract each other. Now bodies B and C repel each other. If A and C are held close together, they will. Option A, repel. Option B, not affect each other. Option C, attract. And option D, information insufficient. So what is the answer? The answer is, so you can see first A and B, they both are attract each other. B and C repel. So here is the solution. Body C is charged. Okay, so body C is charged. Why? Because unlike charges attract, like charges repel. Here B and C are repel each other. So let us consider all possible cases. First case, you can see case 1. AB attract each other because they both are unlike charges. Then if AB attract each other, minus plus means opposite charges. So they can also attract. You can see third case, B and C repel each other. Why? Because negative and negative. And B and C repel each other. Why? Because positive and positive. So in both the cases, A and C have unlike charges. So hence charges A and C are held close together. So they will attract each other. So this is a good example for understanding like charges and unlike charges. So next, what are the basic properties of charges? So first basic property is additivity of charges. So here I have taken 1, 2, 3, 4 charge. Q1 charge, Q2 charge, Q3 and Q4 charge. So in this isolated system, we can add Q1 plus Q2 plus Q3 plus Q4. So here we should take, yes. So you can see in this isolated system, plus here I have taken Q1, Q2, Q3, Q4. Q1 I have taken minus 1, Q2 plus 2, Q3 plus 4, Q4 minus 8. So if you add, you will get minus 3C. So this is the first property of charges. So next is charge conservation. So you can see in the metal sphere before and total charge. So first, what is the definition of charge conservation? The charge is neither be created nor be destroyed and it remains constant. It is always conserved. So you can see before it is minus 4C and total charge is minus 4C. So you can take after minus 1 plus minus 3, it gives minus 4C. So this is the next, this is the second property, conservation of charge. Neither can be created nor be destroyed. So after and before the charges remains same. Before it is 4C, after also 4C. Next, third property is quantization of charge. So you can see in this table, Q1 is 1.6 into 10 power minus 19 C, Q2 is plus 3.2 into 10 power minus 19 2C, Q3 1.78 into 10 power minus 19 C. So here we have taken what is the first, before that, what is the definition of quantization of charge? So all free charges are integral multiple of basic unit of charge, that is Q is equal to N into E. So here N is an integer and E is the charge. The charge is 1.6 into 10 power minus 19 coulomb. So here I have taken 1 into 1.6 into minus 19. Yes, of course it is quantized, but 3.2 into 10 power minus 19, yes, it is existence in nature, but Q3 1.78 into 10 power minus 19, that is not equal to N into E. So that's why it is not quantized. So first and second example it is quantized, but the third one is no. Why? Because it is not existence in nature. So these are the three properties of charges. Here is the one of the example for quantization of charge. A conductor has a positive charge 14.4 into 10 power minus 19 coulomb. The conductor has dash electrons as compared to the neutral conductor. So neutral conductor means there is both positive and negative charges will be there. So charges, they have given the charge is 14.4 into 10 power minus 19 coulomb. So now as the conductor is positively charged, so it is short of electrons. So what you will do, so you can take Q into N into E. So N they have given 14.4 into 10 power minus 19. So N we need to find out. So for that you can multiply with 1.6 into 10 power minus 19. So what you will get, if you divide that, you will get the answer N is equal to 9. So thus the number of deficient electrons are 9. So this is the example of quantization of charge. Next is modes of charge transfer. So the next topic is methods of charging. There are three methods of charging. First one is charges by friction, second one is charging by conduction, third one is charging by induction. So first one is, here I will explain conduction, charging by conduction. So it involves the transfer of charge from one object to the another object. So in this metal sphere, okay, here I have taken a neutral sphere, uncharged body, and here I have taken metal sphere and I have taken plastic rod. You can take plastic rod near to the metal sphere. Just next, you just touch the plastic rod to the metal sphere. Okay, so then what will happen? The charges can transfer from plastic rod to the metal sphere. So this is the conduction method. Next, by friction. You can see in this, so friction means you can take one charged body and uncharged body, rub both of that, then the charges can transfer from one body to the other body. So when one object rub to the other object, so they are charged. Why? Because due to the friction. So you can take the example of glass rod with the silk cloth. Then rub both of the both of the object, so it will get charges, and in both the objects that charges can transfer from one object to the another object. So here we have taken the balloon, rubbed with this cloth, then it can transfer from balloon to the cloth. This is one of the example for charging by friction. Next is charging by induction. So two types. First one is charging by conduction, charging by friction. So the next is charging by induction. So you can see in this method a charged object is brought near but not touched. Okay, so you can take it is just touch to the body, then the charges can transfer from one object to the another object. You can just take near to the shirt. So not touch, just near to the shirt, the charges can transfer from one object to the another object. So this is the last method of charging. So next is materials based on the conduction. So conductors and insulators. So conductors are these materials which allow the electrons or which allow the electricity to pass through them very easily. So these are the examples. You can take these metals and earth. So it can transfer the electricity easily, that is called conductors. And next is insulators. So the materials offers high resistance to pass the electricity. So these are the examples for insulators: glass, plastic, ceramic, rubber, wood, wool, fabric, or paper. So these are the insulators, and also these not allow the electricity easily. Next, semiconductors. So semiconductor means it behaves both insulators and conductors. So these are the examples: ICs, transistors, diodes, capacitors. So these are the examples of semiconductors. So next is electroscope. So here this is one of the device used to find out the charge on a body. So here they have taken, so it is one of the simple operators to detect the charge on a body. So here they have taken rubber, metal leaves, glass, metal knob and metal rod. Okay, so you just touch the metal knob to the metal leaves. So what will happen? It deflect and also it is diverge. So it diverges, then we'll get to know there is a charge on this body. So this is one of the example of electroscope. This is one of the experiment to find or detect the charge on a body. So in this slide we have learned these are the topics we have learned. Two kinds of charge, one is positive and negative charge. Next, charge on the electron. What is the charge of the electron value? 1.6 into 10 power minus 19 coulomb. And what are the properties? Like charges and unlike charges attract each other. Electric charges has a three basic property. One is quantization, additivity and conservation of charge. So these are the terms we have learnt in this slides. The next topic is Coulomb's law. So what is the statement of Coulomb's law? The electrostatic force of attraction or repulsion between the two stationary point charges is directly proportional to the product of magnitude of two charges and inversely proportional to the square of the distance between them. So this is the statement of Coulomb's law. So now you can see, so I will explain the Coulomb's law now. So here you can take two charges. So there is a distance between the two charges, that is r. So here when F is directly proportional to the product of magnitude of two charges and also the F is inversely proportional to the square of the distance between them. So now you can combine F is proportional to Q1, Q2 and also it is proportional to 1 by r square. So then F is proportional to Q1, Q2 by r square. So now you remove the proportionality constant, you will get Coulomb's constant, that is K. So then F is equal to K into Q1 Q2 by R square. So what is K? So K is equal to 1 by 4 pi epsilon naught. So if you solve 1 by 4 pi epsilon naught, so you will get 9 into 10 power 9 Newton meter square per Coulomb square. So what is epsilon naught? It is a permittivity of free space. What is the value of epsilon naught? 8.854 into 10 power minus 12 Coulomb square Newton per meter square. So then F is, the final expression is F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. So that is magnitude of force, it depends on the medium. So next you can see these are the limitations of point charges. So the charges is considered or point charges. So here I have taken the distance is 2 meter and the distance is 2 meter. So it is not applicable to the Coulomb's law. Why? Because so always the distance is applicable when the separation between the charge is large as compared to the dimension. So when it is, so this is one of the limitations of Coulomb's law. The distance is always, it is compared to their dimension, it should be a large. Then here 3 meter it is not applicable. So then 400 meter it is applicable. So these are the limitations of Coulomb's law. So next is, so you can see this, like charges repel each other. So Q1, Q2. So in the statement, the electrostatic force of attraction or repulsion. So here you can see Q1, Q2, it like charges, that's why it is repel each other. So where F12, so this force on Q1 due to the Q2, and I can take F21. So F21 means force on Q2 due to Q1. Then unlike charges. So unlike charges, you can see this is, we are learning the multiple charges. So here unlike charges attract each other. So Q1, it is applying a force F1, unlike plus and minus. Then it is applying force on this. So this is unlike charges. This is unlike charges attract each other. So this is minus, minus or plus, plus. So this is one of the example, you can see one question is there. So 2 point like particles carrying charges 3 into 10 power minus 9 coulomb and 5 into 10 power minus 9 coulomb are 2 meter apart. Then determine the magnitudes of the force between them and state whether it is attractive or repulsive. So you can see here they have given 2 charges and distance also they have given. So now we have to take the formula and we have to prove the force. So here 2 charges are there, Q1 charge is plus 3 and Q2 charge is minus 5. So into 10 power minus 9. Then you can take the formula of Coulomb's law, F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. So that K value we know that 1 by 4 pi epsilon naught is, you can write directly 9 into 10 power 9 into Q1 is 3 into 10 power minus 9 and Q2 is 5 into 10 power minus 9 divided by R, they have given 2 square. So if you multiply and divide it by 4, you will get the answer 3.375 into 10 power minus 9 Newton. So since the charges are unlike, force will be attractive. So this is a good example. So the next is force due to the multiple charges. So here we have taken 3 charges. So then this is point O and it is attracting Q1 and also from point O towards Q2 and also Q3. So here we have taken the distance R1, R2 and R3. So I can write this equation as F1 is equal to F12 plus F13. So F12 means we know that Coulomb's law, K into Q1 Q2 by R12 square into R12 cap. and K Q1 Q2 by Q1 Q3 by R13 square into R13. So this is a force on a multiple charges. So the next topic is electric field. So here I have considered charge. So let us consider charge Q placed in a vacuum. So now, if we place another point charge Q at that point P, at this point P, then the charges Q will be exert a force on that charge Q. So you can take any of the point charge, then you can take the test charge. So it experiences the field or not. So test charge is always positive. So when you take a point charge, then you can take any of the test charge. You can take the test charge or unit positive charge. So this is plus and unit positive charge is also plus. So it is repel. So if you can take in negative charge and test charge, so it experiences the force. So now if you remove the charge, so what it experiences the charge, it experiences the cloud of influence. So now the charge Q is removed. So I am removing the charge. So what is left in the surroundings? So if there is nothing from the point P, then how does the charge force act on the charge Q? So now in order to answer this type of questions, so we can learn the effect of charge by learning the electric field is introduced. So now the electric field due to the point charge. So you can take the charge Q, point charge, and I will take the test charge. So the test charge, what is the expression? Now the distance from charge to the test charge, point charge and the test charge. So it experiences the repulsion. So why it is experiences? Because so here is a plus and here is a plus, and the distance from this charge to this charge is R. So what is the expression for electric field? So E vector is equal to F vector divided by Q test. Then always test charge is positive. Then so what is F? F is equal to, so we know the formula of Coulomb's law, that is 1 by 4 pi epsilon naught Q1 Q2 by R square. So here Q1 is point charge and Q2 is test charge. So Q test divided by R square into R cap. So E vector is equal to F divided by, so what is F? What is F? 1 by 4 pi epsilon naught Q by R square into R cap. So what is the final expression? E vector is equal to Q divided by R square into R cap. So this is the expression for electric field due to a point charge. So what is the SI unit of electric field? Newton Coulomb or volt per meter or Newton per Coulomb. So the direction of electric field is along the force on the test charge. So now you can see for a positive charge, the electric field will be directed. It is electric field, it is directed radially outwards. Why it is radially outwards? So you can see. So you can take the positive charge and take the test charge Q naught near to the positive charge. Then the direction is always outward. So you can take plus. So next near to the test charge. Take near to the test charge. Test charge is always positive Q naught. So then it shows the direction always outward direction. So for a positive charge, the electric field will be always radially outward. Next you can take the next negative charge you can take. So now you can take negative charge. So negative charge and take the test charge near to the negative charge. The direction now positive and negative will attract, so the direction shows inwards. So if the source charge is negative, then the electric field vector shows the direction radially inward. So now we can find one of the example. The magnitude of electrostatic force is experienced by the charge 1 into 10 power minus 6. It is 1.5 into 10 power minus 3 Newton. So find the magnitude of the electric field at that position of the charge. So take F is equal to, we know that the formula F is equal to Q into E. So magnitude, then F is equal to Q into E. So what is Q? What is F? They have given 1.5 into 10 power minus 3 is equal to, what is Q? 1 into 10 power minus 6 E. So we need to find out electric field. So we know the formula of electric field E is equal to F by Q. So that is 1.5 into 10 power minus 3 divided by 1 into 10 power minus 6. So we'll get the answer 1.5 into 10 power 3 Newton per Coulomb. So this is the example of electric field. The next topic is electric field lines. What are the electric field lines? So here you can see it is a curve drawn in such a way that the tangent to each point. So this tangent shows the direction of the electric field at that point. So it is a purely geometric representation and it has no physical existence. So the next is the electric field lines properties. What is the first property of electric field lines? What are the first property? So field lines you can take, when you take the positive charge, it shows the direction always outward. And when you take the negative charge, it shows the direction inward. So first property is field lines started from positive charge. Field lines, if you take a positive charge, it shows the direction outward. If you take the negative charge, it shows the direction inward. And the next property is always the field lines started from positive and end at the negative. And so if you take single charge, it shows the direction outward and shows the direction inward. If you take two charges, positive and negative, so now if you take single charges, it shows the direction like this. If you take positive and negative charges, so the field line shows the direction, it starts from positive to negative like this. So you have to write the direction positive to negative. Then diverge, you have to write positive to negative. You have to write the direction inward. So positive outward, negative inward direction. So field lines starts from positive charged and end at negative charge. So this is one of the property. And the next property is they never cross each other. The electric field lines are never cross each other. So you can take this. Suppose if the charges can intersect, okay, so you can see this. This is a point charge, okay. So the point of intersection, it will not be unique direction. So here, if you write a tangent on this charge, so you will get the direction to that charge. So it will never cross each other. If it cross, it shows the direction of that charge. So that is the next property. Next. So you can see this. The magnitude of this field, it is represent the density of the field lines. So suppose if you take the charge here, if you take near that, then the intensity is more. Then if you are going to take away from this charge, the intensity is less. So here, away from the charge, the field gets weaker. Away from the charge, the field gets weaker and the density of the field lines is less. So now you can see the density of the field lines is less compared to here. Next, the field, when the field line is stronger near to the charge, so now in this you can see the region is strong. The region of the strong field you can see. Why? Because the density of the field line is more near the charge and the lines are closer. So the electric field strength is proportional to the number of the field lines. And the next property is electric field lines. It does not form the closed loop. So these are the properties of electric field lines.